Now, if you're going to go and build a quantum key distribution network, what should you be thinking about? So the first thing you should be thinking about is what quantum key distribution protocol will be used. So in this talk, we've discussed BBM92 and BB84, entanglement-based and prepare and measure version. However, there's many other types of QKD that you could be looking at. There's continuous variable, there is device independent, there's measurement device independent, and we'll reserve those for future webinars or other sort of talks, but they're all very interesting and have very specific purposes for when you might want to be using them. Second, what physical system will the QKD hardware be built on? Are you going to be using entanglement? Are you going to be using quantum communication channels? What are your entanglement sources? What frequencies are they going to be emitting at? Are you going to be using light or some other type of matter qubits? So there's many details about what your quantum hardware will look like. Then once you've figured out the protocol and the hardware, you can then think about how will you scale your quantum key distribution network? How many users do you need to have on it? What distances do you need to cover? Are you going to be using fibers? Are you going to be using free space channels? Many questions to address there. Then this fourth question is, what algorithms will be used for classical post-processing? Once again, there's many different algorithms that could be applied for error reconciliation or privacy amplification. So you need to figure out what's going to be best for your use case. Furthermore, in a similar vein, how much noise is expected and what quantum bit error rate can be tolerated. This is highly dependent on the hardware that you're using and your network sort of architecture and the application at hand. How secure does your secret key need to be? Finally, how could an adversary attack the specific QKD implementation you put together? Based on the hardware you use and the algorithms you apply, every single implementation has its unique threat profile. So you will need to address how adversaries could exploit the system you've built. Now, to address many of these issues, the European Telecommunication Standards Institute has developed detailed specifications and best practices for quantum key distribution networks. So on the left here, you can see they have provided a sample prepare and measure QKD setup, and they have very detailed specifications and parameters for each of the steps involved, including what algorithm should be used in which cases and what kind of architectures should be applied. On the right, we have a high-level sort of architecture for a quantum key distribution network. Here, they're talking about how software-defined networking could be integrated with quantum key distribution, where you have all of these QKD modules, which are connected and basically creating secret keys. But then you have more components to the nodes in the network and their management. You have a key management service, which makes sure that the key material is secured. You have apps, which might be consuming that key material and using it. And then you have an agent that controls the local node. And you also have a network controller, which is managing the sort of key distribution process between many, many nodes.